Okay, now we're ready for the next idea here, next big idea. And that is that we're going to give another name to this. If f is defined, closed interval, and if this limit exists, then we'd say that f is integrable on AB, and that this limit, when this exists, can be denoted by this symbol in here. Notice this looks a lot like the integral that we work with in 4.1, those antiderivatives, except we have these limits on the integration here. Okay, A is the lower limit and B is the upper limit. Okay, so that's a little different. We haven't seen that yet, and that's significant. So let's go ahead and compute this by viewing it as this limit. If we can find this limit, then it's denoted as this, and this therefore exists, whatever this is. Okay, so let's go ahead and work this through. What we're trying to find here is we have to view our f of x is this 3x. And our a is equal to 0, b is equal to 2. So if you think about what we're doing here, we can interpret it this way. You got your line coming in here, and you're going from 1 to 2. And we're going to form in here rectangles. Okay, I'm going to use a right sum, which would necessarily be an upper sum for this one, and to do my calculation. So I'm going to form this sum. And let's see, my delta x would be 2 minus 0 over n, so that's 2 over n. And my c sub I will be I times 2 over n, like that. Okay, so that'll get me started from I equals 1 and so forth. The right side of each of these rectangles that I'm forming over here. Okay, so I'll have f of 2I over n with a delta x. So we'll have 3 times 2I over n, and the delta x was at 2 over n. So this becomes, I'm going to pull out that, in this case it is a 12 over n squared. And inside we just have an I. So we know that's 12 over n squared, and I is n times n plus 1 over 2. That's the sum of I from 1 to n. So this would give us a 6 times n plus 1 over n. And finally, we're going to let, remember, in our notation up here, this indicates here that the norm is approaching 0. Now, in a regular partition, that's the equivalent, of n going to infinity. So when we get down here at this point, finding this limit as the norm, well, here, limit as the norm approaches 0 is the same thing as limit as n goes to infinity. Okay, so n going to infinity here, and so forth. So we just keep bringing that down. No, I'm sorry, apologize for the sloppiness. I should have been thinking this through a little bit more carefully with regard to that notation. But okay, so let's n going to infinity, we can see that this is a 6. Okay, now, so we've got that this thing right here, 0 to 2, 3x dx equals a 6. We just found that because we interpreted it as a Riemann sum. And that Riemann sum could be interpreted as finding area under the curve. So we have an answer, 6. Notice also that we really just have a triangle here that we're trying to find this area for. It's a triangle. is a base 2, height 6, area is 1/2 base times height, which is a 6. So our number fits the number we found.